All right, so for the second half of our lesson, still talking about slopes, for the second half of our lesson, we're going to cover some extra stuff other than just finding slopes, okay? So here we're comparing slopes, right? When you're comparing slopes, what you're looking at is which slope number is bigger, ignoring the positive and negative sign, right? So which one is bigger, okay? And anytime that you have two lines that intersect, you know that one of them will be considered steeper. One of them will have a bigger slope, okay? Always. So if we think about this, right? If Griselda walks home and she walks down a hill on her way home, what type of slope would that be? Negative slope, right? And then Felipe, when he walks home, he walks up a hill, right? You walk up a hill, all right? Okay. All right, so Felipe walks up a hill. What type of slope would that be? Positive, right? Yeah, you're climbing a mountain, right, to get home, right? When you compare to see which one is steeper, do you care if she's walking down the slope or he's walking up the slope? It doesn't matter, right? Who's going to be doing more work, though? Felipe probably walking uphill, right? All right. So what do I have next here? Looking at those two slopes right there, which one is steeper? Right? Which one has a steeper slope? So we have M1 and M2. Why do these two have M1 and M2? What does those ones and twos mean?
Different slopes.
Yeah, they're two different slopes, so I got to name them, right? So I'm naming them slope 1 and slope 2 because I don't have a very creative mind. So I just name them, like if I, yeah. All right, so which one do we think is bigger?
I think the slope that's like higher is number 1.
So you guys are thinking number 1, right?
It's number 1.
How could we show that other than just looking at it? What do you think, Linker? You can turn the half into 16ths, right? And you say, okay, I'm going to multiply the 2 by 8 to get 16, multiply the 1 by 8 to get 8, so we get 8 16ths, 7 16ths, right? Good. Very good use of fractions. All right? But, does everybody in here feel comfortable with fractions? Yes. Some people do not. Do some people like decimals better than fractions? No. So when you are comparing slopes, you can take these and turn them into decimals. What's 1/2 as a decimal? 0.5. What's 7 16ths as a decimal?
0.499.
It's not 0.499. You guys know?
I'll get a calculator.
Let's get a calculator and see. I'm hearing a lot of guessing. I want to hear something for real.
7 divided by 16. 4.375. 4.375. Shut up.
Okay, people, I need the level to be a little bit quieter. I like the interaction, right? But when we start talking over each other, it gets a little too loud. So now, if I have it in decimals, it's easy to see which one's bigger, right? Still, slope 1 is what? What's the word we're going to use, though? Instead of bigger?
Higher.
Steeper, right? Steeper. All right. How about those two, right? I gave these ones names as well, didn't I? There's M. Davis and M. Tinkla, right? So those are just names. So there's Slope Davis. That's the way I go home. I have to go up 42 on my hill. Tinkla goes downhill, negative 43, right? Which one is steeper? Yeah, the Tinkla slope, right? He goes negative 43. We just look at the 43 part, right? When we compare steepness. So his negative 43 has a larger, it's called a magnitude. Okay? Magnitude means I don't care positive or negative. Right? All right. So his is a little bit bigger. Even though mine's positive, his is bigger. All right. Looking at the top one, M1 and M2. Which one's steeper? They're equal, right? So if two lines have the same or equal slopes, what type of lines are those two? Parallel, right? And you guys see right there? Parallel lines have equal slopes, okay? Slopes are equal, which makes sense because if we think of parallel, right? They're never going to touch. They're going to go the same direction the whole time, right? I'll try to do my best to draw some parallel lines, right? I'll call this line 1 and line 2. If line 2 was steeper, wouldn't line 2 like catch up to line 1 eventually? And they'd touch, right? And if line 1 was steeper, wouldn't line 1 catch line 2 like down here somewhere? Yeah. Thank you. All right. So it makes sense that if they are parallel, they have the same slopes, okay? So let's look at these ones down here. I want them to be parallel, right? Here is slope of line A. Linker, what's slope of line B?
3. It's the same thing, Andy. It could be 3 or negative 3.
No. That's a good one. I didn't even think about making that a point, but they have to be completely equal, okay? Yeah, negative 3. You can't do positive or negative 3 and positive 3, even though they would have the same steepness, but we also have the same sign. Yeah, they'd be going same steepness. They'd just be like, psh, psh, sometimes perpendicular. Okay. We have slope of x is unknown. Slope of y is negative 3/4. What's slope of x, Gloria? Thank you. I'm looking for slope of x. Yes. Say thank you to Jessica right now. What's your questions? Those are the same number, right? Yeah. So the question was, could I put negative 0.75? Yeah. Same number, they'd still be parallel, but how do we like to leave slopes? Fractions, right? So you'd be right, but we're trying to leave them as fractions. All right, here we're going to talk about perpendicular slopes. What does perpendicular mean? How? Special, right? They cross and make 90-degree angles. All right? 90-degree angles, that makes parallel or perpendicular. Perpendicular slopes have opposite reciprocal slopes, okay? Kind of sounds like a lot, but it's not bad, okay? So if we look at slope 1 and slope 2, one needs to be positive, one needs to be negative. Does that happen for slopes 1 and 2? Is one positive, one negative? Look at slopes 1 and 2. Is one positive, one negative? This isn't a trick question. Yeah, one's positive, one's negative. The reciprocal part, thank you, Daniel. The reciprocal part is when we flip a fraction, right? So, if I look at these two, negative 2 is really a fraction of negative 2 over 1, right? If you look at those, did the 2 go from the bottom to the top? Did the 1 go from the top to the bottom? Are those two reciprocals? Are they opposite reciprocals? So that's opposite and reciprocals. So that makes it true, right? Because of their opposites. One has to be positive, one has to be negative. Okay, looking at slopes A and slopes B. Okay, I have a question.
Yes, I'm not totally getting you on the negative. Yeah.
So is this one positive?
Yes.
Is this one negative? Has to be.
Could it be negative 1 and positive 2?
You mean like, could you write it like 2 over negative 1?
Yeah.
You could, but it doesn't really matter. Yeah. I mean, like, we'd reduce this to negative 2 anyways, right? But remember, all three of these fractions, I'll make it something else. I'll make it 4, even though that could reduce.
So the 4 could be negative and that was kind of a negative 2.
All three of those fractions mean negative, because there's one negative sign each time, right? So all three of those are the same. The preferred way to write them are the first and the last one. Usually it's just kind of like one of those like etiquette type of things, when your mom tells you not to put the elbows on the dinner table, like doesn't really keep you from eating food, right? But this is putting your elbows on the table in the math world, okay? I don't know where it started from. I don't know where it came from, but I know I'm going to tell my kids because my parents told me, and now it's in my brain that it bugs me, right?
So why'd you put a 1 under the negative 2?
Okay, so, excuse me. The question was, why did I put a 1 underneath the negative 2 here, right? The reason why I did that was just to illustrate that the 1 went from the top of this fraction to the bottom of this fraction, and the 2 went from the bottom of the fraction to the top of the fraction. In actuality, do I need it? No. So I'm going to end up leaving it like that. I just wanted to show you guys the first time. Okay? So looking at slopes A and B, all right, let's ask Dylan that one. Dylan, what sign should this slope be? What sign? Positive or negative? A negative, why? Yeah, this one's positive, so that one should be negative. Okay? Cassie, we're going to have a fraction, right? All right, so I'm going to have a fraction. What number's going to go on the top of my fraction?
5.
And what number's going to go on the bottom?
4.
Good. Oh, I guess. There we go. Right? I can put the negative sign there, can't I? Can I put the negative sign here?
Yes.
Can I put the negative sign here?
Yes.
Yeah, but what? It's like putting your elbows on the dinner table, right? We don't. So it's like a little bit. So we'll put it back up here, right? Okay. Good. You guys understand perpendicular slopes?
Yes.
Okay. Opposite reciprocals, right? What about parallel slopes?
Oh, they're the same.
Same. Okay. Looking at these 3 lines, I want to know which ones are parallel. Okay? Which ones are parallel? How can you tell if they're parallel? Am I just going to eyeball them? What do you got, TJ?
Well, if I had to eyeball them, I'd say the one on the left over here and the one on the far right over here. Is really parallel.
So TJ says eyeballing. He thinks 1 and 3 are parallel, right? But he says 2 doesn't look parallel. Okay? That's eyeballing. Okay? What do you got, Jose?
2 and 3 are parallel.
You think 2 and 3 are parallel. So Jose thinks it's 2 and 3. Okay? Gloria. Okay, I'm calling on people that have their hands up. Gloria. Oh, Gloria thinks 1 and 2. So we got a little bit of every combination there is, right? So would you guys, after seeing that, with 3 people guessing 3 different ways, you guys think eyeballing is the best way to do this one? No. How could we be more precise? Okay. You gotta find the slope, right? So we call these 1, 2, and 3, right? So I need to know what's the slope of 1. Didn't we say that there's 2 ways for us to do this? Yeah. Okay, 2 ways for us to do this, right? All right, Joseph, should I do this rise over run, or should I do this one with y2 minus y1? Which one do you want to do? The second one, y2 minus y1? Okay, so why don't you help me set up the top? What's y, we're doing slope 1, so what's going to be y2? Yeah. Which ones go on top? The y's. So it should be what? 4 take away 0. And what's going to go on the bottom? -2 take away -3. Okay, that's good. Remember, if I put 4 first on the top, then -2 has to go first on the bottom, right? Does that make sense to everybody? Okay. 4 take away 0? -2 minus the -3? 4. So we get a slope of 4, right? Okay, good. Let's ask Brenda. How do you want to do slope 2? You want to do it rise over run, or do you want to do it Joseph's way with the formula? Formula, okay? So how are we going to set up that formula for number 2? Five minus 1. 4 minus 3. 5 minus 1 is? 4 minus 3 is?
I changed my answer.
Hey, good. So we get, yeah, some people need to be changing their answer right about now because we know 1 and 2 are the same, right? Okay. Let me see any hands of anybody that wants, you guys have just been bugged by people doing it the formula way. You're like, just do it rise over run. Who wants to do it that way? Okay. Darren, help me out with slope 3 then, okay? So we're going to do slope 3 with rise over run. So what are you doing? You're counting from here to here? So we go. So I was what? 5, 1, which makes it 5 over 1, which is 5. Which slopes are equal? 1 and 2. So 1 and 2 are what type of lines? Parallel, good. Now, this is how I'm going to write that, okay? Because I don't like writing parallel. Okay, sometimes I forget how many L's are in there. It's confusing, right? Yeah, they kind of look like the L's, right, in parallel. So I'm going to say line 1 parallel line 2. Okay, good job. Okay, line 1 parallel line 2. And this makes sense, right? Parallel. The only thing is I like to make those parallel signs a little bit bigger than I make my numbers, so it doesn't look like an 11. All right. All right, here we're going to draw a perpendicular line, okay? We have line H, which goes through those 2 points, and we want to graph the one perpendicular to H through the point 2, 5, right? So what do I need right now? Graph paper. All right, and then I think I need to zoom out 1, maybe 2, 7, 6. Yeah, okay. All right, so I probably need to graph that line, right? How can I graph a line if they just tell me 2 points? What do you think? Yeah, when we're drawing a straight line, we only need to draw 2 points to draw a straight line, right? And we have points 3, 0, so that's here. All right, and we'll give out. There we go, 3, 0, and 7, 6, right? Once we have 2 dots, right, we can just draw a line through them. If you see me try to draw a straight line, I better start cheating. Okay? Okay, now, I want to draw a line perpendicular to this, right? And this is line H, right? I want to draw a line perpendicular to H, and it goes through the point 2, 5. So that's, oh wait, I can't. So 2, 5, it's like here, right? So just eyeballing, right? It looks like it should probably come through like, right? Like that, right? Ish? 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 Okay. So how can I find out exactly where it goes though, right? Talking about perpendicular, what do we know about those slopes?
They have opposite slopes.
Opposite reciprocals, right? So now we need to find the slope of H, right? So I need to say, hey, what's the slope of H? Okay? Brian, help me out with the slope of H. Yeah, you, Brian. Well, you tell me. Do you want to do a formula way or do you want to do rise over run? Rise over run, okay? So, hey, too much talking. Rise over run, so. How many was that? You can't see? Do you stand up and walk around here? And then how many was it? You better get up and walk around here because you're blind. All right? Brian's got to get closer to the classroom. I'm glad you waited until now to tell me you can't see the board. Right? You've been sitting there for a while now. So. A little bit closer, a little bit closer. There we go. How about this way? You want to borrow my glasses tomorrow? Okay. So it's 6 over 4, but I can reduce that, can't I? 3 halves. All right. So if slope of H is 3 halves, what is my slope of, we'll call it the perpendicular. What's the slope of the perpendicular going to be, Stephanie? Is this number positive or negative? So this one should be? All right, and then it's going to be a fraction. What number is going to go on top? And what number goes on bottom? Not that bad. Okay. Now let me clean up my drawing a little bit. There we go. I'll clean up that a little bit. Now, slope is just rise over run, right? Okay. So from my point, 2, 5, I'm going to rise how much?
You're going to fall down to.
Fall down 2. So 1, 2, okay? And then how much am I going to run? 3, okay? 1, 1, 2, 3. So it's going to go right through here. Okay? Now, I'm going to take this time right now to stop somebody from doing the mistake that somebody will do. Okay? Somebody will see this and they will go down 2 and then go back 3. Somebody will. All right? I heard Darren try to do that, right? Because the minus sign is just out here in the front, right? You might think that, but how many minus signs are there? 1. So you can only do one of them as negative, okay? Now, if you think the 3 is negative, right, which is the bottom, which we said was like putting your elbows on the table, right? But it can be negative. That means instead we'll be going up 2, back 3, and they hit the same line, don't they? Right? So if you mess up and start doing it the other way, are you going to be wrong? No, you get the same answer, right? Just your elbows are on the table. Okay, page 175, 1 through 25, okay? Yeah.